The formula for partial sums of an first n terms of a geometric series is S sub n equals a sub 1 parentheses 1 minus r to the power of n close parentheses divided by 1 minus r. This is the formula we use to find the partial sum of a geometric series. Okay, so we want to find the sum of 2 plus 4 plus 6 dot 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 to 32. So we know that a equals 2 because it's the first term, and to get r we just divide the second term by the first term, so that equals 2. And we want to know what n is. Just ignore this for now. So to find n, you put a sub n equals a sub 1 r to the power of n minus 1. That's the formula to get n. So we know an, because the last term is 32. We know that it's 32, and then we plug it in. And a sub 1 is 2, and r is 2 as well. So we put it in the formula, and then we get 16 equals 2n minus 1. So by getting that, we divided by 2 by both sides. And now we want to get rid of the 16 and make it equal to 2. So we put it to 2 to the power of 4 equals 2 to n minus 1. And now that the bases are the same, you can make 4 and n minus 1 equal to each other. So you get n equals 5, and then you just plug everything into the formula, and then you end up with 62. So for this one, this time we know that a sub 1 equals 3, and that r, because 6 divided by 3 equals 2, so r equals 2. So what we do now is, again, we have to find n. So the formula is a sub n equals a sub 1 r n minus 1, or r to the power of n minus 1. So a sub n is 192. So 192 equals 3 parentheses, well, I'm sorry, not r. We know what r is. Parentheses 2, close parentheses, n minus 1. So we divide both sides by 3, and that should give us, hold on, let me do this in my head real fast. That should give us 64. So 64 equals 2 n minus 1. And then we want to get 64 to be equal to 2, have the same base. So then we know that 2 to the 6th power is the same as 64. So now we have the same base, and 6 equals n minus 1 plus 1 plus 1, so n equals 7. So we could fill that in. N equals 7. Okay. And then we just plug it into the formula. So S sub n equals 3 parentheses 1 minus 2 the 7th power all over 1 minus 2. So S of n equals, let's see, what's 2 to the 7th power? I think it's 128. So 128 minus 1 is 127, times 3 is 381. So it's 381. And that's it. So let's try to do one more. So this time we're just gonna have a sub n. Well, here, let me fix that for you. A sub n equals 2 parentheses negative 2 n minus 1, and n equals 4. So we want to find s sub 5 equals a sub 1 minus 1 minus r to the n over 1 minus r. So we want to find r. So we're gonna have to use this formula. So r equals a sub n over a sub n minus 1. So I went ahead and wrote out the problems. So if we want to find a sub 1, the first one, so we just plug in 1 for n, and we find out that it's 2. And then we find the second term, we plug in 2 for n, and we get negative 4. So now we still want to find r, so we do the formula. The second term divided by the first term equals r, so negative 4 divided by 2 equals negative 2. So that's what r equals. So now I think we have what we need to plug it into the formula. So I made a little mistake over here. I just didn't write 4, I put 5 by accident. So that doesn't change anything majorly, but I went ahead and I wrote down the formula and I plugged everything in, and now we just have to find out. So right here and right here you can see that the signs actually change and turn into a plus. I don't know if you ever learned that little plus thing. So 2 to the power of 4 is 16, plus 1 is 17 times 2 is 34, divided by 3 because of the bottom equals 11.3. So the answer would be 11.3. So there you go. So here are some practice problems. The answer for number 1 is right here. The answer for number 2 is right here. And these problems were gotten from the AP Calculus AB and BC exams 2013. So that's my source. And thank you for listening.